Assalamu alaikum friends. Today I am going to show you that there exist some patterns in carbohydrates, especially aldohexoses. You can also call these patterns as periodic tables, because you will see that these patterns will be arranged in groups and periods. Bismillahirrahmanirrahim. I will be showing you two different kinds of patterns in aldohexoses. So let's see pattern number 1 in aldohexoses. Let me show you the names of the aldohexoses first. We have allose, maltose, galactose, glucose, glucose, idose, mannose, and talose. These are the 8 different aldohexoses, and you can see that I have arranged them in alphabetical order. As you all know that all these sugars will contain 6 carbons, and carbon number 1 in all of them will have the aldehyde group. So this is carbon number 1, carbon 2, 3, 4, 5 and 6. So all of them have 6 carbons in them. You can see that at carbon number 1 all of these 8 sugars have the aldehyde group. The carbon number 6, last carbon here, this is the carbon that has 2 hydrogens attached to them. So there are a total of 3 different groups attached to the last carbon, and it is not involved in making any stereoisomers of the sugars. That's why we are not taking carbon number 1 as well as carbon number 6 in our patterns. Another carbon that is although important with respect to making the capital D and capital L sugars, but in today's lesson I will not include carbon number 5 in my patterns, because it will not change allose to any other sugar, for example into altrose or galactose, etc., if you change the orientation of the hydroxyl groups at carbon number 5. For example, you have glucose, and the hydroxyl group on the carbon number 5 is on the right side. Then if you change it to the left side, it will still remain glucose, but only the enantiomeric form will change. That is, at first when it was on the right side, it was the dextro sugar, dextroglucose. When the orientation of the hydroxyl groups was changed to the left side, then it became the L isomer of the L enantiomer of the glucose sugar. So let's hide these 3 carbons, because we are not taking them in our pattern today. Before starting the pattern, let me tell you a rule that I have also shown you in my previous videos about carbohydrates, that the rule says that the alphabetically first sugar will have all the hydroxyl groups on the right side of the carbon number 2, 3 and 4. So in allose, because it is alphabetically first sugar, it will have the hydroxyl groups of carbon number 2, 3 and 4 all on the right side, while talose, which is the last sugar alphabetically in aldohexoses, it will have all the hydroxyl groups on carbon number 2, 3 and 4 on the left side. So these are also not included in our pattern today. So let's hide them too. Now let me show you the pattern. The pattern is start from maltose, because allose is already done, and we know that carbon number 2 in allose sugar is on the right side, carbon number 3, carbon 4 as well. So altrose will have hydroxyl group on the second carbon on the left side. Then you will have to leave blank spaces. But how many blank spaces? 3 blank spaces. 1, 2 and 3. So 3 blanks. Then we will have double L. So L and L. It means that idose and mannose both have hydroxyl groups on the second carbon on the left side. So this is the pattern that will be repeated for carbon number 3 and carbon number 4 as well. So what is the pattern? The pattern is L, blank spaces, and then double L. Now for carbon number 3, the pattern will be written in reverse order. That is, you will start from mannose. You will start from the sugar where you have ended the pattern. So the pattern has ended at mannose. And now you will start in row number 3, or you can say in carbon number 3 from the right side. So the pattern will be left, and then we will have blank spaces. But this time the blank spaces will be 2, not 3. So blank space and blank space. And then as I showed you in the, as you can see, the pattern on the carbon number 2 is L, and then blank spaces, and then double L. So the same situation will be on carbon number 3 as well. That is, first L, and then blank spaces, and then double L. So L and L. Now our pattern has ended on galactose. And now in the carbon number 4, we will start from galactose. That is, where your pattern ends, it will start in the next row from the same sugar or in the same group. So the pattern again will be L and blank spaces and then double L. But this time the pattern will be from left to right. So L, blank space, and so this time the blank space will be only 1. And then L, and then L. So this was the whole pattern that exists in these sugars when you arrange them in alphabetical order. So what is the pattern? Single L, and then blank space or multiple blank spaces, you can say, and then double L. So this is the pattern: L, blank spaces, and double L. First in carbon number 2, the pattern will be written from left to right, and then in carbon number 3 the pattern will be written from right to left, and in carbon number 4 the pattern will be written from left to right again. What about the spaces or the blank spaces? In the second carbon the blank spaces will be 3, in carbon number 3 the blank spaces will be 2, and in carbon number 4 there will be only 1 blank space. So these L represents that the hydroxyl groups in these sugars, on these carbons, are on the left sides. What do the blank spaces represent? These blank spaces represent hydroxyl groups on the right side in these sugars on the same carbon. For example, in galactose, you can see the hydroxyl group on carbon number 2 is on the right side. While in the same galactose, carbon number 3 and carbon number 4 hydroxyl groups, they are on the left side. And now what about glucose? You can see in glucose, carbon number 2 and carbon number 4, they are on the right side, while hydroxyl groups on the carbon number 3 is on the left side. So this was the whole pattern. All of the blank spaces left will be on the right side. Now let me reveal all the other hidden parts of this periodic table. You can see all the remaining blocks will show the hydroxyl groups on the right side. So now the periodic table of aldohexoses is complete. So this was about pattern number 1. So what is the pattern? It is L, triple R, and then double L, and then the same group, but in the next row you will repeat the same pattern. That is L, and then blanks, and then double L, and then where it ends you will start the same pattern in the next row from the same group. That is L, and then spaces, and then double L. Now let's see the second kind of pattern that exists in these sugar if you arrange them in this order as I am going to show you now. If you type these sugar names in this order, first allose, that altrose, glucose, glues, mannose, idose, galactose, and talose. As you know that we are only interested in carbon number 2, 3, and 4. So the pattern will only be for carbon number 2, 3, and 4. And in the beginning I told you that alphabetically first sugar will have these hydroxyl groups, that is carbon number 2, 3 and 4 on the right side, while tallows will have all these hydroxyl groups on the left side. You can divide this table into two groups. This is group number 1 and this is group number 2. As you can see, in group number 1, all the 3 sugars will have only one hydroxyl group on the left side, while 2 on the right side. While in the second group, that is on the group you can see on the right of the screen, is are the sugars, that is mannose, idose and galactose. They will have only one hydroxyl group on the right side, while 2 on the left side. You can see the pattern. In ultrose, the hydroxyl group of the carbon number 2 is on the left side, then glucose have the hydroxyl group on the third sugar on the left side, while glucose have the carbon number 4's hydroxyl group on the left side. Now let's see the other group. They will have only one hydroxyl group on the right side. So in mannose, you will have the hydroxyl group of carbon number 4 on the right side, and then in idose, the right side hydroxyl group will be on the third carbon, while in galactose only the second carbon's hydroxyl group will be on the right side. So you can see that this is also a very beautiful pattern, and these two patterns, if you memorize them, will help you in memorizing the structures of these carbohydrates. So thank you very much for watching my video. Bye.